Welcome to a special International Petroleum Technology Conference live session. Today's session is the IPTC Excellence in Project Integration Award session. My name is David Blanchard. I am the IPTC Award Committee Chair and President, WTM Energy. Each IPTC, the IPTC Excellence in Project Integration Award, is given to a project that adds value to the industry and exemplifies strong teamwork, solid geoscience knowledge, reservoir and engineering acumen, determined and watchful construction, and outstanding facilities engineering practices. Equally important, successful projects require a pervasive culture of HSE that focus on sustainability and a positive impact on the country, the region, and indeed the world. The IPTC Excellence in Project Integration Award session provides attendees with the opportunity to gain in-depth knowledge about the finalists' projects and ask questions. So the finalists for this 2021 IPTC Excellence in Project Integration Award are Culzean by Total, Ichthys LNG by INPEX, Khurais Arab Light Increment by Saudi Aramco. Each finalist will now provide a 15-minute presentation followed by 10 minutes of Q&A. Please submit your questions via the comments section. So now I would like to introduce our first speaker, Stuart McCauley, Petroleum Architect Total, to present Culzean by Total.
Hi, my name is Stuart McCauley. I was the engineering manager and facilities manager for the Culzean project, and today I would like to give you a brief overview of the field and the project itself. So where is Culzean? Culzean is located in the UK North Sea. It's around 200 kilometres offshore from Aberdeen and very close to the UK-Norwegian border. It sits in around about 90 metres water depth. Environmental conditions here are very harsh, and also it's an extremely well regulated sector. So the technical requirements for any development in this region are very, very onerous, leading to safe and efficient performance of the facilities, but a challenge for any project team. In terms of the project itself, the field was discovered in 2008. It's expected to produce for at least 13 years with a design life of 25 years. And the ambition for Culzean really is to become a hub for other similar developments in the area, to open up the exploration and the development of other resources close by. The project had a budget of around $4 billion, and indeed it's created 400 direct jobs in the area, and also is currently delivering around 5% of the UK gas demand. Total, as operator, we developed the field and currently operate the field alongside our partners BP, who have 34% stake, and JX Nippon, who have a 16% stake. In terms of the timeline, as I mentioned previously, the field was discovered in 2008. We then went on to a planning phase, and between 2009 and 2011 planned and executed a further 3 HPHT appraisal wells. That allowed us to go into a concept selection phase and ultimately kick off and execute FEED activities between 2014 and 2015 on a new platform complex. In 2015, we had reached a technical and commercial solution that allowed us to fully sanction the project and take it through FID. Now, the challenge with HPHT projects of this scale is actually the length of time it takes us to drill the wells. So with 9 months, up to 9 months to drill a single well, in order to have enough wells available at startup to reach plateau efficiently, we had to start drilling in 2016. That meant we had to place contracts and install a wellhead jacket prior to our project sanction, and also commit to the new build of the Maersk Highlander rig, which was contracted to drill the Culzean wells. So that was done before sanction. After sanction, we were able to start building the main facilities, the 30,000 tons of topsides for the 3 platforms, as well as the FSO for the condensate storage. That came together and was completed in 2018, with the facilities being installed in the field in the summer of 2018. What then followed was a 10-month hookup and commissioning period, which then allowed us to achieve first gas in 2019. And 2019 was the date that we had promised when we kicked off our FEED activities in 2014, and it was the date that we had promised in our investment proposition in 2015. So the exploration and drilling itself. Actually, although the exploration well was drilled in 2008, it wasn't the first well on the field. In 1986, so 25 years before the exploration success, a well was attempted. However, given the drilling technology of the time and the extreme conditions of this ultra HPHT field, the well was unsuccessful and had to be abandoned before reaching its reservoir target, with no real data recovered. In 2008, though, the field was revisited. The structure was very obvious. However, the challenge around drilling it was what had delayed any further progression on it. But in 2008, the 2225A9 well was drilled. It had an extremely challenging drilling window. However, that was successfully managed and proved up a large gas column. Over the next 2 years, a further 3 wells were drilled, and those wells effectively proved up the resources that allowed us to justify the development of the field. The challenge here, though, was that not only did we need the volume, we needed to understand the challenges with developing in ultra high pressure, high temperature environments. So we're dealing with 13,500 psi, 175 degrees C. So that's 5 times the pressure of a normal reservoir, double the temperature. And therefore, the challenges around ensuring that we can deliver safe and operable facilities. Complex, high-integrity safety systems are required. Extreme focus on materials and materials selection and the design of specialist equipment. It all leads to additional cost, additional time, but more importantly, it's all around about being prepared. So for the Culzean field, front-end loading was essential. The reservoir itself that we encountered, it was a very large gas column, very good quality, 78% net to gross, 17% average porosity. It was primarily, the primary reservoir is in the Triassic, so over 200 million years old. It's a relatively dry gas, the very little condensate, so a low CGR. For our 500 million scuffs that we produce of gas, we produce only around about 15,000 barrels a day of condensate. There is a lot of vertical compartmentalization, so therefore large vertical wells are required with large perforation intervals. The compartmentalization is caused by the lateral and extensive shales in the field. As we now have more production data, we're starting to understand more how the field is structured and how best to further develop the field itself. In terms of the wells themselves, they're very high producers. Obviously, we have these extreme pressures, which allow us to produce at very high gas rates. And therefore, for the large reserves we have, we only actually require 6 production wells. We have 6 production wells and 1 drilling well. And as of the end of 2020, all those wells have now been successfully delivered by the project drill campaign. Very challenging wells, obviously, with the pressure and the temperature, and also the vertical depth. We have they're 5,000 meters below the seabed. At the time when we were looking to place these drilling contracts, it was in a very buoyant market, and in 2013 we went to the market and we took the decision that the best option for Culzean was to go with a new build rig. So the contract was awarded on the basis of a new rig being built. Hercules Drilling were the company that won that. Unfortunately, due to the downturn, which challenged many of both the project and many, if not all, of our suppliers, they went into administration, and so the rig was taken over by Maersk and Maersk Drilling, and they then mobilized it to the field and successfully executed the drilling campaign. To execute this drilling campaign of these high-tech, high-risk wells, not only ahead of schedule and on budget, was an achievement. To do it with a new rig, the first deployment of that rig really was exceptional. The challenge with the materials, both in the wells and in the facilities, is just the pressures we're dealing with here. So all the components are designed to deal with over 1,000 bar pressure at 175 degrees C, with also contaminants such as CO2 and H2S. So therefore we end up with systems where we have to use very exotic materials. So the majority of the topsides is actually built through 25 chrome. That is a very difficult material to work with and to weld. So huge amounts of QA, QC is carried out around about testing and checking constantly from the moment the steel is produced in the mill to the point it reaches the field. Also a huge amount of pre-investment in all aspects of the project around about working with these materials, and the onerous safety systems we had in place required a huge amount of training and preparation to successfully achieve what we did eventually achieve, which was top quartile performance. An extremely low weld failure rate during the construction phase, actually lower than far lower pressure systems, and that was all down to the preparation and the training put in. So the facilities themselves, we have a 3-platform concept. Over 30,000 tons of facilities are installed in these platforms across 3 jackets. On the right-hand side, you can see we have the wellhead platform over which our rig, the Maersk Highlander, is drilling at that point. In the centre, we have the 14,000-ton central processing platform, which effectively separates the gas and the condensate before export to the UKCS. And to the left, we have the utility and quarters platform. So completely hydrocarbon free, and the whole design premise of this field was round about a safety gradient. Keep the people as far away from the high pressure wells as possible. And that's what we achieved with this configuration. Although we don't produce a lot of condensate, it's quite difficult to handle. It has a high wax content, and therefore we decided to install a dedicated floating storage and offloading vessel, the FSO. We also decided not to use a conversion. We felt from operability and environmental standards, it was easier to design a vessel as a new build that was then tailor-made for our specifications. It also gave far greater certainty on outturn cost and schedule. And therefore we built the FSO in Singapore with Modec and Sembcorp Marine. Subsea-wise, we also have a significant subsea element to this project. We export 57 kilometres of gas export line to allow Culzean to send its gas to the UK trunk line through the CATS system. And we also have a 3-kilometre line to our FSO. Although it's a UK project, it was very much a global footprint. We built topsides in Singapore. We built some decks in Batam. We built our jackets in Holland. We built some modules in the UK. We built our subsea systems in Scotland. So we used small teams, highly integrated teams, and that allowed us to make sure that the interfaces were well managed and we had no delays from any issues between the different units. One of the key elements for us also was to ensure that this was our digital flagship. So build today what we'll need tomorrow. And really our idea was that by incorporating that principle from the very start of the project in FEED, we were able to future-proof and design for what we knew just now and what may be coming along. So effectively we were making the interface between offshore and onshore as seamless as possible. Mobile data for the offshore operators, live data streaming for the guys onshore, and ultimately it's to improve efficiency, to make us be able to do work onshore, which previously we would have had to send people offshore to do. So in terms of the scorecard for the project, most importantly, we did it safely. We managed to finish the project after more than 40 million man-hours expended with a TRIF of 1.02, which we consider to be a significant achievement for such a complicated and complex project. We had delivered ahead of schedule. We delivered in June 2019, 2 months ahead of our promise in our investment decision. We didn't re-baseline, we didn't reschedule. We hit the date we predicted in 2014 that we would start up production on. We were able to actually save around about $500 million in capex through efficiencies in the drilling campaign and also good management of our facilities spend. So we didn't have to use a lot of contingency that was in the original budget, as we worked well with our main contractors. OPEX savings also from our digital twinning and the work we put in with the operations team from the start. And that meant that early work with operations meant that we were able to get early first gas because operations were fully involved in both the design, the construction, commissioning, and then the startup itself. So all in all, an achievement that we were very proud of. A true mega project delivered on time, on schedule, providing UK gas for the UK market. Thank you, and I look forward to any of your questions at the next session. Thank you.
Well, thank you for an insightful presentation, Stuart. Let me start with a question while the audience submits theirs. There you are. Okay. So let me ask a question for you. What were the main reasons, aside from the early completion of the drilling, for Total's ability to come 10% under FID budget and ahead of schedule?
Yeah, David, obviously the performance of the drill rig was very important in that, and that helped us a lot. But also our ability to control costs during the execution phase was key. And that's an area that can often see significant overruns. What we focused on in Culzean really was two main areas. We were very keen to do a lot of front-end loading. So we did a very comprehensive FEED exercise such that we could understand fully what we needed to build and what we wanted to build. We also ensured that our teams were clear that what we were asking our contractors to build, that's what they had to, that's what we were requesting. We didn't change throughout the process. So it allowed our contractors, working closely with our contractors, to manage the change and therefore manage the cost, and therefore they were able to come in on the budgets. That was backed up really by a strong contracting strategy. We set a number of fixed price lump sum contracts for the different elements. Some may think that's slightly outdated, but it worked very well. And if you can work collaboratively with your contractor and not confrontationally, then you can get an outcome where everybody succeeds. We succeed in delivering on the initial budget. We had virtually no variations on the initial lump sums, and our contractors were still able to make money from it. So that's a good outcome for everyone. The second part was around about giving our teams, we actually work with very small teams. We give people accountability and responsibility to deliver. We were able to make quick and nimble decisions throughout the process. And I think that was also very important in terms of managing cost, managing scope creep, and maintaining progress, which is ultimately linked to the cost.
Oh, absolutely. Absolutely. Very good. Well, let me ask another one here, another question if I can here. Between the digital flagship concept and best of existing technologies, and with natural gas replacing or maybe preempting coal-fired plants, can you provide kind of an approximate figure of carbon credits you expect over the life of the project?
I don't have the exact figure at the moment, David, here, but that was a key element of Culzean. Ultimately, the driver for developing Culzean was to support the UK market in that move from coal-fired power to reliable supply for gas-fired power stations, which it has done. It's a mature basin also, though. So, finding large reserves such as Culzean is key in that strategy and that transition. So that's on if you like, on the highest level where we see the benefit of something like Culzean being developed. As we come into the design, though, we were always looking from the start and from the feed to look to minimise the requirements to send people offshore and maximise the efficiency of our plant where possible. And ultimately, that's where you can save a lot in terms of both carbon credits, but importantly, reducing emissions by being able to operate plant very reliably. And I think that's something that our digital flagship concept, that's ultimate. Data is one thing, but what are you trying to use it for? And we were looking to use it to make sure that we had as efficient and low emission plant as possible. And if I look over the last, if you watch, I still receive the daily reports from the platform. We consistently hit 100% uptime on that platform. And I think a lot of that is to do with that mindset of building operability, building in a digital approach from the start.
Very good, very good. No, that makes a lot of sense, the way you've handled that. Now, maybe I can ask another question here, unless we have one from the audience. So you started drilling, you said ahead of schedule, which was great, due to and you were ahead of schedule due to efficiencies. Were these driven by the lessons learned by Total and other of Total's mega projects? For example, in West Africa, I know you had a lot of experience down there. So just kind of maybe state what other kind of lessons learned and how you got so far ahead of schedule, I guess.
Yeah, I think a lot of it is down to planning very, very early. So our drilling and subsurface teams for the project were mobilized way before we were even in the feed stage, and they were looking to this execution phase very, very early. I think the difficulty with HPHT is that it has to be fully integrated. Because the wells take 9 months to drill, if you want to have 4 wells for startup, that means you have to start a number of years earlier. So therefore, you have to finalize that planning, not just within a drilling team, but within the subsurface team to identify the targets early, develop the models, and merge with the facilities team and be able to take large chunks of the development forward and take that pre-FID risk. So a lot of that was down to the planning was very well done there. We actually benefited hugely from the HPHT drilling community. It's an area where operators tend to share openly lessons learned. It's very important, obviously, due to the risk associated with these wells. So we were actually able to pull on quite a broad industry experience, of which Total has a significant amount of experience in the Elgin Franklin field, for example, of both development drilling, but also bringing lessons learned back from the if you like, the midlife, late life operation of these wells. That was shared and brought back to the front end, which allowed us to develop robust planning, good preparation, investing in early preparation, which, if you like, almost future-proofed some of the issues you may have encountered in a conventional drilling program. And that allowed us to stay on track there. There was also an element of thinking ahead and again integrating between the teams of. We adopted a batch drilling focus. So for each section we did the top hole, in a number of wells. Then we moved on to the next section, the next section, the next section. And that was very useful especially when we had a new rig. It's the first deployment for the Maersk Highlander and its crew, that you could get that repeatability on each section. You could prepare the rig, then we drilled in sections, then we did the next section, then we did the reservoir sections. So that again worked very, very well on this project, and that was another major part of being able to actually get ahead of the schedule that we had set initially.
That sounds great, Stuart. Thanks for that further information and additional insight into the project. Very impressive. Thank you. So our next speaker is Bill Townsend, Vice President Corporate with INPEX, to present the Ichthys LNG by INPEX.
Good day, everyone. It's a pleasure to be speaking to you today about one of the largest and most complex resources projects ever undertaken, Ichthys LNG. My name's Bill Townsend, and I am INPEX Vice President Corporate, based at our Australian headquarters in Perth, Western Australia. Ichthys LNG has been an exciting journey for INPEX and our Ichthys joint venture participants. For those of you who may be unfamiliar with INPEX, we're Japan's largest oil and gas exploration and production company. We're currently involved in more than 70 projects across 20 countries. The Ichthys story began in 1998 with the granting of an exploration permit to explore an area 220 kilometers off the very remote northwest coast of Australia. Our first exploration campaign in 2000 and 2001 involved 3 wells and led to the discovery of what we know today as the Ichthys field. Approximately 40 kilometers by 20 kilometers, the Ichthys field comprises 2 giant reservoirs, the Brewster Member and the Plever Formation. Resource estimates for the field are around 12 trillion cubic feet of gas and 500 million barrels of condensate. Ichthys is one of the few energy projects to incorporate the whole chain of development and production: subsea, offshore, pipeline, and onshore. Developing Ichthys was unbelievably challenging, but don't take my word for it. Have a look for yourself. This video will help you understand the size and scale of Ichthys.
Ichthys LNG is one of Australia's most exciting and challenging energy developments. INPEX made Australia's largest liquid hydrocarbons discovery in more than 50 years within the Browse Basin. Located 220 kilometres off the north coast of Western Australia, the find, known as the Ichthys field, is estimated to contain more than 12 trillion cubic feet of gas and 500 million barrels of condensate. In 2012, INPEX rewrote the record books and raised $20 billion to sanction Ichthys LNG, one of the largest and most complex oil and gas projects in the world. Essentially 3 mega projects in one, Ichthys LNG incorporates some of the world's biggest and most advanced offshore facilities, an 890-kilometre pipeline, and massive onshore processing facilities near Darwin. Ichthys LNG is expected to operate for at least 40 years and incorporates the whole chain of development and production: subsea, offshore, pipeline, and onshore, a rarity in the global oil and gas industry. Ichthys Explorer, the central processing facility, is the world's largest semi-submersible platform. It features hydrocarbon processing systems, utilities, and worker living quarters. After initial processing, most of the condensate is transferred to Ichthys Ventura, the nearby floating, production, storage, and offloading facility for offshore processing. The 890-kilometre gas export pipeline, the longest subsea pipeline in the southern hemisphere, is delivering natural gas and some condensate to the onshore processing facilities near Darwin. Here the gas is transformed into a liquid to reduce its volume for shipping. Purpose-built state-of-the-art onshore facilities include 2 LNG processing trains, LPG and condensate processing plants, storage tanks, and a jetty with 2 loading berths. Ichthys LNG is expected to produce, at capacity, up to 8.9 million tonnes of LNG per annum, 1.6 million tonnes of LPG a year, and up to 100,000 barrels of condensate a day at peak. The start-up of production in 2018 marked the beginning of INPEX's transition to an LNG operating company. With cargoes regularly departing from Ichthys LNG's world-class facilities, the focus is on continued safe, reliable and efficient operations for the next 40 years. INPEX, we're here for the long haul.
As you can see, this development is massive. Designing, constructing, and commissioning Ichthys created tens of thousands of jobs around the world, took over 400 million work hours, and has created a lasting economic and social legacy in Australia and beyond. With topsides weighing around 78,000 tons gross and topsides measuring 130 meters by 120 meters, our Ichthys Explorer Central Processing Facility is the world's largest semi-submersible platform. It displaces 155,000 tons. The CPF is designed to remain permanently anchored in the field for the next 4 decades. Moored just 3.5 kilometers away is the Ichthys Venture Floating, Production, Storage, and Offloading Facility, or FPSO. The FPSO processes and stores most of the condensate delivered from the CPF until it is offloaded to carriers for export directly to market. The FPSO measures 336 meters long and 60 meters wide and can store more than 1.1 million barrels of condensate. It's one of the most advanced FPSO facilities ever built. Both the CPF and the FPSO are designed to work as a single unit. An electrical interconnector has been installed to share power and provide redundancy between the 2 facilities. The CPF also has some process control over the FPSO. Our offshore personnel have access to high-speed data and voice communication services via subsea fiber optic cable network, enabling them to stay in touch with onshore operations and their loved ones at home. The offshore facilities are designed to operate safely even in strongest tropical cyclone conditions. Despite their scale, the facilities were designed primarily with safety and functionality in mind, using fit-for-purpose technologies so our teams could operate them safely and intuitively. However, beneath the waves is where the technology story is really different. Such a remote and challenging field requires new and innovative thinking. Ichthys's subsea and subsurface infrastructure is some of the most extensive and complex in the world. Our subsea production system and the umbilical, riser, and flow lines set new benchmarks in engineering. The production system includes a huge electrical fiber optic and hydraulic distribution hub connected to the CPF, 5 distribution units, 18 production Christmas tree systems, and 5 production manifolds. The Ichthys vertical Christmas trees operate at temperatures up to 155 degrees Celsius, an industry first. The umbilicals, riser, and flow lines connect the production system to the CPF and the CPF to the FPSO. With nearly 190 kilometers of flow lines and umbilicals, it is the largest scope completed within a single project in Australia and one of the largest worldwide. The Ichthys URF team worked an incredible 1,294 days straight in tandem with the drilling team to lay the pipework and umbilicals. They completed more than 3.6 million work hours without a single lost time injury. Through the first phase of completing 18 development wells, many challenges were addressed to maximize well productivity through design changes. Ichthys contains many feats of engineering, but a standout is the gas export pipeline, the GEP. At 890 kilometers, the GEP is the longest subsea pipeline in the southern hemisphere and the 5th longest on the planet. At 42 inches in diameter, it is constructed from more than 74,000 pipe joints. It's coated in concrete and weighs approximately 700,000 tons. The GEP transports natural gas and some condensate from the field to the Ichthys LNG onshore processing facility in Darwin. Some challenges while laying the pipeline included shallow water pipe laying and crossing major submarine cables in Darwin Harbor. And now to onshore. Ichthys LNG's onshore processing facilities are situated on a 520-hectare site near Darwin. A modular construction approach was taken to minimize the amount of building works required at the site. In a world first for an LNG facility, we installed a 500 megawatt combined cycle power plant to support the onshore facility Combined cycle is around 50% more efficient than a traditional single-cycle power plant. Given the size and complexity of Ichthys LNG, coordinating all the different components simultaneously, managing up to 30,000 people worldwide during construction, and making sure the project was completed safely and to the required quality was a huge challenge. One of the biggest achievements was to create and embed the necessary health, safety, environment, and quality HSEQ management systems and culture almost from the start. A bespoke engineering, construction, and production-based HSEQ system to drive the right behaviors and comply with the stringent Australian regulatory framework was created. The dredging campaign to make Darwin Harbour accessible to LNG carriers was one of our environmental success stories. More than 16 million cubic meters of sediment was removed from Darwin Harbour with minimal impact on the environment and the community. This was done using cutting-edge technology, quite literally. We used the most powerful cutter suction dredge in the world at that time. This eliminated the need to drill and blast in Darwin Harbour. In recognition of the successful dredging campaign, in 2014, we received 2 national industry awards. Technology, passion, and innovation have been vital to conserving our natural environment and enhancing our cultural heritage. We also changed our proposed jetty design to ensure access was maintained to popular creeks to allow fishing to continue there. Ichthys has changed the economic landscape of the Northern Territory with more than $12.5 billion flowing through the local economy because of project activity during construction and operations. Over the life of Ichthys, it is estimated to generate $195 billion in exports for Australia, $190 billion in additional gross domestic product, and support 1,800 full-time jobs per annum. In addition, INPEX and the Ichthys LNG joint venture are making meaningful contributions to the Northern Territory's culture and education, which includes a $91 million social and environmental voluntary offsets package. As a socially responsible energy company, we are actively focused on accelerating our response to climate change. We have set 2 emission goals. By 2050, we will aim to achieve net zero in absolute emissions, encompassing Scope 1 and 2. As an interim goal, we will aim to reduce our net carbon intensity by 30% or more. In Australia, we have invested in savanna fire management and biosequestration projects and are considering further initiatives to deliver energy in a sustainable way. Developing Ichthys pushed the boundaries of project engineering and integration, bringing together people from a multitude of cultures from around the world to build something truly special. Most importantly, Ichthys was developed with an unflinching focus on safety and social responsibility, establishing a legacy that continues throughout LNG operations. Ichthys LNG is our big, bold venture, which has and continues to benefit many. It's been my pleasure to share our Ichthys story with you. Thank you.
Thank you for that detailed presentation, Bill. Very good. While we review the questions from our viewers, I'll kick off the discussion with a question. You mentioned, of course, several things in HSE and social responsibility. What will it take to reduce the emissions to net zero by 2050, as you mentioned?
Well, thanks, David. It's great to be with you and with our international audience here today. The net zero by 2050 commitment is, of course, very timely, and I'll give an Australian response to begin with, which is that it's going to take a lot of hard yakka, and hard yakka means a lot of hard work. I mean, I don't mean to be flippant about this, given this, seriousness of the issue. But I think we do need to be realistic about it, that this is something that is going to take a village really to resolve. And I think if I look at Ichthys LNG as an example of a project that got executed, you saw the size and scale of it. I think that should give us some hope that we'll be able to tackle the net zero challenge by 2050. And by that, I mean, when we were developing Ichthys, I can recall the early days when we looked at the size and scale of what was ahead of us. And at times we didn't necessarily know how we were going to get through it, but we knew that we had to. And at some point we came up with the idea that what we were really about was willpower. That became our tagline. And really willpower meant that we had to succeed no matter what. failure was not an option. And I see the same around net zero by 2050. We may not know today exactly how we're going to get there, but failure is not an option, and with willpower, we'll get there. And the components of willpower, if I think about them, are around commitment, they're around technology and innovation, and perhaps most importantly, around collaboration. Collaboration not only across the industry, but across sectors and with other parts of the economy and with governments. So yeah, I think it's a huge challenge. If I think about Ichthys specifically, this will be staged. We've installed a state-of-the-art plant in Darwin. It has a combined cycle power plant, which is very efficient. So it's already a very efficient power plant. However, there's still room for improvement there. We'll continue to look for ways to improve the technology of our operating facilities. We've committed to eliminating routine flaring by 2030, for example, and we'll continue to look for that. And we're investigating other opportunities such as carbon capture and storage, which in my mind is going to be essential for the success of net zero by 2050.
Yeah, thank you, Bill. I think you're right. It's the willpower and just not having the option to fail is really where we're headed there. And I think your idea of staging is quite good in case, say, regulations might change on that. So let me ask another follow-up question. What plan does INPEX have to sequester carbon? You mentioned perhaps CO2 storage. Do you have any sites and sufficient storage capacity that have been perhaps identified? And was a feasibility study done prior to the FID of this project?
Well, Ichthys LNG was identified with carbon capture in mind. So what we did when we were designing and constructing the facilities is we left room for carbon capture and storage technology to be installed. At the time of our FID and then subsequently of our first operations, the CCS opportunities weren't viable, but I think they're becoming more realistic by the day, and we continue to investigate that. We have done extensive work to identify potential traps for the CO2, including some aquifers not so far from Darwin where our onshore facilities are located. So we're working to progress those. I mentioned before when I talked about this willpower and taking a commitment, technology, innovation, and collaboration, that if I take the collaboration piece out there, I think what we're looking at is working with our industry peers as well as with government to perhaps create a CCS hub, for example, where multiple users could use the same trap for an aquifer, for example, to capture the CO2. So with Ichthys, we have identified a likely or a strong candidate for geosequestration, and we'd be pursuing an appraisal well as the next step for that.
Well, that's great, Bill. Thank you. Thank you very much. I appreciate you providing that extra information and on a great project, outstanding project. Thank you very much. Appreciate it. Okay, so our final presentation is about the Khurais Arab Light Increment. So at this point, let's get started with that.
The Khurais Arab Light Increment Program is a milestone in Saudi Aramco's journey, a point at which the power and potential of the fourth industrial revolution have been unleashed in ways that are reimagining what a modern oil field is and what it can be. Khurais is pushing the envelope of 4IR, deploying technologies that allow operators to control well completions, detect pipeline leaks, as well as numerous other tasks safely and remotely. In this sense, it offers a real-time glimpse of the future. With this presentation, we're pleased to describe the Khurais project's key components, as well as several of the technologies that put it at the cutting edge of an industry in the midst of a digital transformation, and how all this was implemented despite the geographical spread in more than 500 kilometers of harsh desert environment, and the challenges that the project faced in the previous years. At its heart, Khurais expansion was designed to maximize hydrocarbon production in the most cost-effective manner possible. And at this scale, that was a massive undertaking. To appreciate Khurais' contribution to helping meet global energy demand, if Khurais was a country, and if we were to compare it with 2020 OPEC production countries, excluding Saudi Arabia, the Khurais capacity would be the 7th highest producing country on the list. Detailing the scope, Khurais has successfully boosted production capacity by 300,000 barrels of crude oil per day to reach 1.5 million barrels of crude oil per day by installing new gas oil separation facility and stabilization plant, where more than 4,770 pieces of equipment were installed. In addition to crude production, Khurais Increment program will boost the capacity to process a total of 867 million standard cubic feet per day of associated gas and 100 million barrels per day of NGL. This is achieved by constructing and commissioning gas processing and condensate stripper facilities. A total of 9,700 pieces of equipment were installed. Beside the main Khurais processing facility, a satellite gas oil separation plant was constructed for satellite fields with a total production of 200,000 barrels per day. A total of 3,200 pieces of equipment were installed. To ensure reliability and customer satisfaction, the latest technologies for product quality were installed, including NGL dehydration, crude desalting, and a de-oiling unit for disposed water. In addition, the project ensures flexibility in crude export and capacity management with the installation of additional crude storage capacity and shipping pumps. In Saudi Arabia's desert environment, off-plot piping poses significant challenges. Khurais expansion saw some 350 kilometers of off-plot piping constructed for oil, gas, and seawater pipelines. In parallel to the expansion of oil production, seawater injection capacity was increased through the installation of 2 gas turbine injection pumps that will enhance reservoir recovery, while 4 heat recovery steam generators utilize exhaust flow gas from the turbines to produce required steam. To enhance asset integrity, Khurais sought to reduce the use of metallic piping in the field. The team installed more than 900 kilometers of non-metallic piping, which puts Khurais at the forefront of the deployment of non-metallic piping in the company and in the region. Additionally, a pipeline leak detection system was installed, using high-impact multi-phase flow pipeline management to detect pipe leakage along a 240-kilometer network, 24/7. With fiber optic sensors, the system is capable of spotting a leak at precise locations in real time, with minimal physical inspection required. Beyond maximizing hydrocarbon production efficiency, the Khurais expansion project was developed and executed with a strong commitment to energy conservation and environmental preservation. Flare gas recovery technology to recover purge flare that will help reduce the carbon footprint. In addition, a swing line for compressors allows load sharing and the shutting down of 1 HP compressor. To maximize energy conservation, a combined cycle cogeneration facility enables power to be self-generated, contributing to a 70% reduction in power demand from the national grid and reducing yearly OPEC cost by more than $50 million. In addition, an in-house developed APC system is the world's first advanced process control to optimize power consumption of well-driven ESPs through automatic adjustment of downhole and wellhead parameters. This technology eliminates the need to do so manually. These initiatives led to a 23% reduction in Khurais' carbon footprint and an 80% improvement in energy efficiency. At the same time, a corporate objective to preserve local resources is seen with the facility's seawater treatment plant. This involved the construction of a 70-kilometer seawater pipeline with 350,000 barrels per day water capacity and includes a reverse osmosis facility to eliminate the use of the kingdom's precious groundwater supply. Various kinds of water treatment are utilized based on intended use. For example, nanofiltration technology was deployed to reduce sulfate content in seawater for injection into a reservoir where there is an incompatibility with unfiltered water. The project also uses an in-house developed patented technology, the Smart Water Flood, to provide a specialized ionic-treated seawater injection to provide higher oil recovery. And the powerful stream produced from the plant is used to recover hydraulic energy, generating maximum value from every drop of water used. Khurais project scope included the implementation of new automated systems that fully eliminated disposing any oily water to the open environment and recycle it within the process. The local flora and fauna are also taken into consideration with a biodiversity relocation plan encompassing an area of 62 square kilometers and a vegetation transplant and regrowth plan, which included more than 18,000 plants. Khurais is considered one of the world's largest intelligent oil fields, where cutting-edge technologies help integrate the reservoir with surface facilities end-to-end, instantaneously. By pushing the envelope of the fourth industrial revolution, Khurais is deploying technologies that allow operators to control well completions, detect pipeline leaks, as well as numerous other tasks safely and remotely. A high-speed fiber infrastructure connects subsurface sensors with a centralized surface location, encompassing literally hundreds of wells and thousands of devices, basically creating a parallel digital world. Khurais includes the 150-kilometer by 40-kilometer intelligent oil field, equipped with more than 40,000 Industrial Internet of Things (IIoT) sensors, fed by more than 700 state-of-the-art multi-phase flow meters, which enables us to remotely operate around 550 electrical submersible pumps and 90 smart well completion. In addition to employee safety, well-being has been prioritized. New residential buildings and recreation facilities help ensure that emotional well-being is never taken for granted, especially during the challenging times brought about by the pandemic. But nothing of this scope comes easy. Vision requires resilience, and the Khurais expansion project faced numerous challenges along the way, almost from day one. The project began scoping and design in September 2013, with a contract signed in October 2014. At roughly the same time, the world witnessed a sharp drop in crude prices, slashing more than 50% of its original price by December 2014. This proved to be an early test of the project's feasibility. Extensive review of the execution schedule and cash redistribution were conducted to put the project on track within the new environment. Cost and design optimization were revisited, leading to a redistribution of the project cash flow. Another challenge was the complex interface between new and existing facilities with more than 3,300 points. The project adapted modular pipe rack strategy, which allowed the safe and efficient integration of green and brown fields. The most formidable challenge in the Khurais story came in September of 2019, when the Khurais facilities were attacked, temporarily interrupting oil production. In a display of resilience that was truly one of the company's finest hours, the Khurais operations team managed to put out the fire successfully, with no reported fatalities on the ground. But damage was significant, and the company relied heavily on the project team, proponents, and contractors to restore and recover. Remarkably, this was managed efficiently within 10 days, returning Khurais to full production potential and maintaining the expansion's progress. And of course, in 2020, the COVID-19 pandemic presented yet another unexpected challenge. Pandemic control procedures, logistics, and manpower were put in place immediately. A business continuity plan was implemented while maintaining production and project execution with no impact or risk to business or personnel. Quickly adapting to the new normal, the team at Khurais delivered production at full capacity comfortably during April and May of 2020. Beyond resilience, vision also requires collaboration. And the expansion at Khurais saw Saudi Aramco working closely with both our local and global partners. The project involved a total of $1.8 billion worth of purchases from more than 60 global partners across 22 countries. Fully 30% of the investment is allocated in local content and capabilities, including significant involvement of local contractors and local talent. In addition, Khurais expansion supported local manufacturing development by providing employment opportunities, especially in highly sought-after high-tech areas. Two examples are the establishment of the first non-metallic piping manufacturer in Saudi Arabia and working with local partners in localizing big stabilizer columns manufacturing. Putting things in numbers, during Khurais project, more than 540 kilometers of piping were installed, 18,000 kilometers of cable were laid down, 13,600 tons of steel applied, 747,500 cubic meters were poured, and more than 19,600 pieces of equipment were mounted. Moreover, through every phase of the project, safety has been the top priority. With more than 10,000 employees and contractors on site at the same time, managing safety performance proved to be a huge challenge. Yet with dedication, determination, and an absolute commitment to work safety, we achieved more than 55 million hours of incident-free construction. 55 million hours that saw 0 on-the-job incidents, 0 leaks, 0 flaring, 0 production interruptions. This is an impressive record of accomplishment that will long be remembered in the history of our company. Over such a large area, the massive data collected provides insights that are leveraged through the use of artificial intelligence, robotics, and many other technologies. Some of the technologies used at Khurais might have been considered science fiction only a few years ago. For Khurais, the future is now. Khurais project has developed an in-house smart performance solution using ML predictive and prescriptive analytics to optimize fuel gas in boilers. The application, which includes proactive culture, contributed to fuel gas savings of $2 million per year, CO2 emissions reductions by 8%, and 2 granted U.S. patents. Also, Khurais project deployed robotic technologies to enhance job safety by eliminating major scaffolding erection work and to optimize maintenance resources while reducing costs and improving efficiency. Technology deployment at Khurais has been so significant, in fact, that the World Economic Forum has hailed the plant a lighthouse of the fourth industrial revolution, naming it to its prestigious global lighthouse network of manufacturing facilities. Khurais project that stood against all odds will remain a proud jewel for Saudi Aramco and the industry for achieving excellence in all aspects. A true testimony of people collaboration, of our employees and partners locally and from all over the world. It has also been a milestone on many fronts for Saudi Aramco and the Kingdom. Having overcome numerous challenges, it stands as a testament to the power of perseverance and technological advancement to help us reimagine what is possible for our company, for our industry, for the world. Innovation will be Khurais' legacy, and it is a legacy we are building in real time.
So thank you for that in-depth presentation. So we're going to get some questions from the team, or we'll have questions for the team who worked on the Khurais Arab Light Increment. Joining us are Mazen Al-Jaid, the Khurais Development Division Head of Saudi Aramco, and Naif Al-Sadhan, the Khurais Production Engineering Division Head, Saudi Aramco. So let me start with a question, if I may. Did the environmental safeguards built into the facilities also contribute positively to the reason that the facilities were brought back online so quickly after the incident in 2019?
Good morning, David and everyone. Indeed, the safety and environmental safeguards built into the facility design was very helpful in bringing it back to full production in 10 days. For instance, the closed drain system was very useful to contain drainage effluent when the facility was shut down during the attack. And then later, this was recovered in a timely manner as soon as the facility was ready to start again. Also, the high safety standards implemented by Aramco in the facility's design were very effective during the attack. Example for this is the equipment spacing and plot layout, fireproofing of the equipment and their structure, the emergency shutdown and isolation systems. All of this had a major impact on limiting the damage from the attack.
Very good, very good. Thank you. You also mentioned in the presentation the implementation of the various IR4, 4IR technologies. Can you elaborate a little more on how technologies like this support management of the Khurais field?
Yes, one of our main objectives in Khurais is to demonstrate how an oil field will look like in the future. We have deployed 4IR technologies throughout the entire supply chain, from subsurface to surface, making the largest intelligent oil field in the world. As a result, Khurais was recognized by the World Economic Forum, which included Khurais in a global network of facilities that are leading the deployment of advanced technologies. In addition to reducing power consumption, these technologies have resulted in reducing maintenance costs and inspection times. They have also enhanced reliability and increased operational response time. Such technologies include big data analytics, machine learning, smart sensors, and remaining useful life forecasting system. There's also a pipeline management system that provides leak detection and real-time security alerts using 24/7 fiber optic network sensing.
Very good. Excellent. Excellent. And just kind of keying off that perhaps a little bit is what have been the most or what have been the most tangible production benefits of the Khurais field being a smart field? So in other words, what kind of production benefits do you see from this this setup in the field?
Well, excellent question, David. Well, and Khurais Saudi Aramco being an having an I-field infrastructure and equipment with more than 40,000 sensor has helped us have a remote monitor and control of more than 1,000 wells that we have here, both surface and downhole equipment. And this, we're talking about 1,000 wells that are just scattered across a very vast geological area. For example, wells that are equipped with smart well completion that is fully integrated with our SCADA system has helped our engineers have full control over different laterals in multilateral wells, equipped with, of course, inflow control valves from the comfort of their office to fully optimize these wells. Now, in the past, having to travel and go to the field would have been both time-consuming and challenging in sometimes. Now, the overall benefit of such utilization has increased our oil production by almost 15% from these wells and reduced our water production by almost 35%. And this is just one of the major benefits that we had from the utilization of the smart well completion, David.
Excellent, thank you. Maybe one last question, if I can. You know, with the statistics you showed up there were quite impressive. I think it looks like the reduction of the carbon footprint is about 23%, and that's quite impressive. What metric did you use to arrive at this number? And can the number of the percentage of reduction, 23% approximately, does that compare to other fields, or how did you get this reduction and a number? And then can this figure be reduced further?
Well, this is compared to the same fields at Khurais before the project, and the carbon footprint in Khurais was reduced by 400,000 tons of CO2 equivalents in 2020, and it is expected to be reduced even further in 2021 as we maximize the operation of the new facilities. There are a few initiatives that we have implemented that made this possible. For example, the installation of highly efficient combined cycle cogeneration facilities using the dual pressure HRSG and steam turbine generator eliminate the fuel gas burning to generate power. Also, an innovative flare gas recovery system using jet pump technology recovers continuous purge gas during our normal operation. There are also other consumption reduction initiatives, such as the industry's first deployment of advanced process control system in an oil field, swing line between gas compressors at different oil plants, the utilization of variable speed coupling and in the propane compressor and injection pumps. Implementing all these initiatives resulted in reducing the carbon footprint by 23%, as you mentioned, and we are committed to achieve even further improvements by continuing to optimize our operation. And also, as the technology evolves further, we will seek even better environmental performance.
Well, thank you to the panel, Mazen and Naif, our speakers from Saudi Aramco, for providing us with more detail about this exceptional project. So thank you all for our speakers. I want to thank them all for their insightful presentations and candid discussion on these world-class projects, and they really are indeed world-class mega projects. Please join us for the IPTC 2021 opening ceremony on Tuesday, March the 23rd at 1300 hours UTC to learn which finalist is the recipient of the IPTC 2021 Excellence in Project Integration Award. So you can register now at 2021.iptcnet.org. Thank you, everybody, for your great presentations and for the audience for joining us.